Alright, our goal here is to solve this maximization problem given in the table below. And this is a standard maximization problem, and we're going to be using the simplex method for it. And so we start off by looking for our pivot. We see in the bottom row the largest negative, or the smallest number overall, is really this -6. So the Z column will be our pivot column, and then to find our pivot row, we're going to take that last value and divide it by the value that's in the pivot row. So I'm going to take 4 and divide it by 1, and I've got 18 divided by 3, and that's 6. Again, I want the smaller of those two values, so that would be the 4. So that means the top row is our pivot row, and the 1 there in the Z column is what we want to pivot with. Now what I want to do is use that 1 to create zeros in that Z column there below the 1. So I'm going to take -3 times row 1, add it to row 2, and put it into row 2 spot. That will give me a 0 where that 3 is. And the other operation I'm going to do is 6 times row 1 plus row 3 and put it into row 3 spot. Alright, and I'm going to go ahead and write that over here. The top row is going to stay the same. I'm not really modifying it at all. It was the X column, the Y column, the Z column. I've got two slack variables, S1 and S2, and I'm trying to maximize P there. Alright, so if I do -3 times 2 plus 1, that's a -6 plus 1 will give me a -5. -3 times 0 plus 1 is going to stay 1. -3 times 1 plus 3 gives me 0, which I was hoping to get there. -3 times 1 plus 0 would be -3. -3 times 3 is going to be -9. Plus -1 gives me -10. -3 times 0 plus 0 stays 0. And -3 times 4 is a -12. -12 plus 18 leaves us with a +6. And then our second operation, 6 times row 1 plus row 3. 6 times 2 is 12, plus -5 gives us 7. 6 times 0 plus 0 is 0. 6 times 1 plus -6 is 0. 6 times 1 plus 0 is 6. 6 times 3 is 18. 18 plus 2 makes 20. And then 6 times 0 plus 1 is 1. And 6 times 4 is 12. Add the 24, sorry, 6 times 4 is 24. Add it to the 22, and that will take us to 46. And now I see that our bottom row is all positive, so that means I'm at the ideal solution. And then to pick that out of the table, I'm looking at this first equation. X is messy. The X column is messy, so I'm going to set X equal to 0. The Y column looks nice, and the 1 lines up with the 6. So Y would equal 6. Z looks like a nice column again. It's got the 1 and all the zeros, and the 1 lines up with the 4, so Z is equal to 4. S1 is messy, so I'm going to set it equal to 0. S2 has all sorts of messy numbers in it, so I'm going to set it equal to 0. And the P has a 1 that lines up with the 46, so P is equal to 46. So our maximum value is 46 when X equals 0, Y equals 6, and Z is equal to 4. And we will have 0 values for our slack variables. We'll be using up all of our resources.